In this section, we will be covering systems of linear equations and different methods on how to solve them. So in general, systems of linear equations is when you have two or more equations that share variables. So you're going to be seeing several examples today where you have two equations and they both have like x and y. We're going to be going over three different methods to solve a system of linear equations. The first method is solving by graphing. The second method is what we call the substitution method. And then the third one, it has two names. It's called the elimination or the addition method, whatever you want to call. And it's very important to understand that you can use whichever one of these methods to solve the problems. I'm going to be going over all three methods, but at the end of the day, it just depends on which one you prefer. So first thing I'm going to go over is how to solve by graphing. We're going to go and discuss all the methods and then we'll do some examples together. But the first one is when we solve by graphing. What you can do is if I give you a system of equations, so if I give you two equations, you could graph both of them. And it's super easy because the solution and the answer is going to be the point where all the equations intersect. Now, there's going to be different scenarios, so you have to be aware of them. If you graph two equations and they look like something like this here where they intersect, that means that you do have a solution. The solution is going to be this little dot where they intersect. So you have one solution. If, for example, you graph two equations and there are parallel lines, and if you don't know what parallel lines are, two lines that never meet, that means that you're never going to have a solution because they're never going to intersect. So if you graph two equations that end up being parallel lines, then that means you have no solution, and that's okay. The third scenario is where you graph both lines and they actually end up being the same line. So if you graph this, you're going to have one line, and then when you graph the second equation, it's going to be on top of the first line. So that means that it's going to be intersecting consistently with the other equation. So that means that you have infinitely many solutions. So these are the three different scenarios you can run into when graphing. So don't freak out if you graph them and the two lines never intersect. All you do is just put that they don't have a solution. So no solution. And again, don't freak out because I did freak out the first time I did this. When I graphed a line, I graphed both of the lines and I thought my calculator was messing with me because only one line showed up. But it turned out that both of the equations were on top of each other. So it's two lines in one, which means that they just have many solutions because they're intersecting all the time. So just be aware, there's always going to be three scenarios. You can have one solution, no solution, or infinitely many solutions. Now, the second method we're going to be talking about in this video is what we call solving by the substitution method. So this is what you're going to do. It's going to be 4 steps long if you prefer to use this method. I'm going to go over them again. I don't expect this to make sense until we actually work out a problem together. Step 1, if you're going to use the substitution method, you have to make sure one of your equations is solved for either x or y. And again, you could do whichever is easier for you. So you have to make one of the equations start with either x equals or y equals. If you get lucky, the problem is already going to be set up like that, but if not, you're going to have to do that. Once step 1 is done, step 2, you're going to substitute the x or the y, whichever one you solved for in step 1, into the other equation. Okay, so I'm sorry about that. It should just be 1 into the other equation. Step 3, you're going to solve for one of the variables. So once you solve, you're going to end up with the answer for x or y. And then obviously step 4, you're going to have to find the missing variable. So in step 3, if you find x, in step 4, you're going to find y. In step 3, if you found y, then step 4, you're going to have to find the x. You're going to have to find both of them at the end of the day. Again, don't worry if this made no sense. It's going to make sense, I promise, once we do an example. This is called the substitution method. Now, the third method we talked about, or that I mentioned earlier, is what we call the elimination or addition method. So from now on, don't freak out if I just call it either or. It's the same thing. Some people call it elimination, some people call it addition. And again, it's also 4 steps long. Step 1 is on this one, if you're going to do the addition method, you have to make sure that both equations look like this. Okay, you're going to have to have your x on one side along with the y. And then on the other side, you're going to have the number, the constant, the one that doesn't have an x or y. So you're going to have to make sure both of your equations look like this. Once they both look like that, step 2 is that you're going to have to manipulate the equations. You're going to have to multiply one or both equations so that the coefficients of one of the variables, either x or y, are opposites. And in case you don't know what opposites mean, is that they're the same number but different signs. So you could have a 3 and a -3. You could have a 7 and a -7. They have to be opposites. Once you manipulate the problem, so the coefficients are opposites of each other, then step 3, you're going to add the equations. Since the coefficients are going to be opposites, when you add them, they're going to cancel out. That's why it's called the elimination method. So your 3 and your -3 are going to cancel out. Your 7, your -7 are going to cancel out, whatever number you have. And the good thing about elimination is that in step 3, you're going to have the answer for one of your variables. Now, just like the other method we discussed earlier, step 4 is going to be finding the missing variable. So in step 3, if you found x, then in step 4, you're going to be finding y and vice versa. So those are the 3 different methods that we talked about. Now, how do you know if we have one solution, no solution, or infinitely many solutions when using the substitution or elimination method? It all comes down to this, right? So we already talked about this right here. We talked about what happens or how to find the answer in graphing. But if you're solving the equations manually using the substitution or elimination method, this is how you know which type of solution you're going to have. If you're solving the problem and obviously you get an answer, then that means that, fine, you have one answer. But let's say I'm solving the problem and now for some reason variables cancel out and I end up with a false statement. A false statement is something like 0 equals 7. That's obviously false. So then you just drop your pencil, you stop, and you tell me that this is going to have no solution. Okay, so again, you don't have to graph it. While you're solving it by hand, you're gonna come to that turning point where you're going to be able to say I have no solution. And now the third scenario is, again, if you're solving the problem, all your x's and y's canceled out, and you are left with something like 5 equals 5. Obviously, that's a true statement. So again, you just drop your pencil, but you could tell me that this problem will have infinitely many solutions. Again, I know you're like, oh my goodness, this seems like a lot. Don't worry. It doesn't make sense because we haven't done an example yet. So we're going to do an example right now, and you'll know exactly what. And this is just extra information for you. I'm not going to test you on this, but it's probably going to show up on your homework, so just be ready. When you have one solution, we call the problem consistent and independent. Consistent means that it has an answer, and independent, it means that there are 2 different lines. If you graph a problem and you end up with no solution, we call it inconsistent because it doesn't have a solution, but we still call it independent because you have 2 different lines. Now, if you're solving a problem and you end up with infinitely many solutions, we call it consistent, again, because you have an answer, but we call this one dependent because the 2 lines are the same line. Okay, so again, you don't have to know these, but I'm just throwing that extra information in there so you don't freak out if you see it on your online assignments. All right, let's go ahead and get started. We're going to start solving some problems here. Obviously, this problem is solved by graphing because you graph them together. I did all the hard work for you. I already graphed them. The first thing I want to show you is just how to find the solution. So here we have 2 problems that were graphed. In case you want to know how to graph these problems, I'll quickly show you, but again, I already graphed them for you. If you want to graph this right here, again, you can use your graphing calculator. You could use decimals.com, but I'm going to show you how to graph them by hand. Anytime you have something like this where the y equals is already on one side, this right here is your y-intercept. So I start at -4, which is right here. And then this right here is what we call our slope. I'm not going to get too much into it. I'm just going to show you how to graph by hand real quick. This right here is what we call your rise. It tells you if you're going to go up or down. And this right here is your run. It tells you if you're going to go left or right. So from my y-intercept of -4, I'm going to rise 1. So I rise 1. And then I run 3. Since it's positive, I'm going to run to the right side. So 1, 2, 3. I make a dot. And then I just connect the lines. Look at that. That's how I graphed the first equation. Now to graph the second equation, I start at +2, which is right here. And then remember, this one's negative. So I'm going to rise -2. So since negative, instead of rising, I'm going to rise down. I know that makes no sense. But I'm going to go down 2. And then I'm going to run 3. Again, the 3 is positive. So I'm going to run 3 to this side. So 1, 2, 3. And then look at that. That's how I graphed that line. Again, that was just a super quick recap. Again, I don't expect you to do this unless you're going to do it by hand. But again, you can use decimals.com. You can use your calculator. Now, the whole point of graphing them is that now I can find the solution. Where do these 2 lines intersect? So they intersect obviously right here. So believe it or not, that's my solution. This number right here is 6. Remember, you always start with your x value, comma, this number right here is -2. So there you go. My solution is simply 6, -2. All of these solutions for these problems are going to be ordered pairs. So you have to give me an x and you have to give me a y. So I think that was pretty fun. Let's go ahead and try one more by graphing. Here we have two equations. Obviously, the first equation is already ready to graph. Again, we're going to do this by hand. The 3 is going to be my y-intercept, and then the 2 is going to be my slope, my rise and my run. But in order to have my rise and my run, I'm going to rewrite the 2 as a fraction. In order to do this, I always put a 1 underneath. So it's going to be 2 over 1. Okay, so whenever you have a whole number, just put a 1 underneath, and that gives you your slope. So that's going to help me graph it. Now, the thing is that for the second equation, I cannot graph it because it's not set up properly. So what I'm going to do is I'm going to move things around to leave the y by itself. So first thing I'm going to do is I'm going to throw the 2x to the other side. So I'm going to have negative 6 and the 2x becomes a negative 2x. And then I'm going to divide everything by 2, just so that I can have the y by itself. So I'm going to be left with y. The negative 2 over 2 simplifies to negative 1 over 1. And I know what you're thinking. I know it's just negative 1. But remember, I have to leave it as a fraction because it's going to help me rise and run. And then the negative 6 divided by 2 gives me the negative 3. So with that being said, my y-intercept for this problem is going to be negative 3. And my slope is going to be negative 1 over 1. So I'm so sorry about that typo. It's negative 1 over positive 1. Sorry about that. Okay, and then I graphed this. Again, I cheated. I did use decimals.com, but I'm going to show you real quick how to do it by hand. So if I wanted to graph the first one, I would start at 3, which is right here. And then I have a slope of 2 over 1. So that means that I rise 2 and I run 1. So I did those 2 dots, I connected them, and that's how I created the line. Now for the bottom one, I have a y-intercept of negative 3, so I start at negative 3. And I have a slope of negative 1 over 1, right from here. So that means I'm going to drop 1, right, because of the negative, and then I'm going to run 1 because of the positive 1. I connect those lines and I create the blue line. And that's pretty much it. Obviously, you could see the solution already. The solution is the point where they intersect. So this is negative 2, negative 1. So that's my solution for this problem. Just a little warning though, if you are going to do these by hand, just make sure you draw your lines super straight, because if not, then they are going to intersect in the incorrect point. So again, just use decimals.com if you prefer. It's going to make it super easy to find the point where they do intersect. So if you need help with that, if you need help graphing these on your graphing calculator, just let me know and I'll help you with that. All right, that was fun. Now let's go ahead and try the second one, the substitution method. Like I said, these two equations can also be solved by graphing. So if you prefer graphing, go for it. But we're going to do here the substitution method. Okay, so for the substitution method, step 1 was that we have to have an equation. We have to solve an equation for either x or y. Lucky for us, if you notice, this second equation is already solved for x. How do I know? The x is by itself in one side. So for us, step 1 was already done. It doesn't matter if it would have been y, it's okay, as long as one of the variables is solved for. So the second equation is already solved for x. So now we move on to step 2. Step 2 says that we have to substitute it into the other equation. So hopefully I don't lose you here, but this is what we're going to do. This whole thing here is equal to x. So I'm going to come and I'm going to substitute it into the x of the other equation. When you substitute, you have to do it into the other equation. So that's what I did. So if you notice, this whole 7y plus 37 took the place of the x. The x is no longer there. It was substituted by this. Again, the only reason I was able to do that is because this whole thing, they're telling me, is equal to x. So I can substitute it into the x. Okay, so that is step 2, substituting. Obviously, now we're going to have to solve this. So again, it just took the place of the x. The 2y is still there and the 8 is still there. So with that being done, step 3 is actually going to be solving. So this, again, is from the previous slide, and then we're just going to solve. So in order to solve this, I am going to have to distribute. So negative 4 times 7 gives me the negative 28y. Negative 4 times 37 gives me the negative 148. The 2y and the 8 just drop down. That's it. Remember, the negative 4 is only distributed to whatever was inside the parentheses. From here, we can start solving, you guys. From here, it's going to be super simple. Negative 28y plus 2y gives me negative 26y. The negative 48, I moved it to the other side and it became a positive 148. So when I added it to the 8, it gave me 156. Okay, so I just combined like terms, the number, I moved it to the other side with the other number. That's how I got that. And then from here, hopefully you know what to do next. When you have a y with the number in the front, you divide both sides by the number in the front. So I divide both sides by negative 26. Obviously on this side they canceled out. And then just double check for me, but 156 divided by negative 26 gives us the negative 6. And look at that, that was super awesome. We're already done with one of the variables. So we know that y is negative 6. So I have half of my answer. This answer is going to have a negative 6 here. So now step 4 says that we have to find the missing variable. So I have to find x. Now here's the thing. To find x, obviously you already know what y is. So now you could just come and replace that y into whichever one of these equations that you want. Just make sure you make a note of it. You could use whichever one you want. To make my life easy, I just use the bottom one because the bottom one already has the x by itself. So I use the bottom one. The y I already know is negative 6. So I put the negative 6 on the y. So that's how I got to this step. And then from there, we just solve. So negative 6 times 7 gives me negative 42. And then I add the negative 42 and the 37, and that gives me that x equals negative 5. Oh my goodness, I hope you guys had fun. This one was really fun. And there you go, that's my solution, negative 5 comma negative 6, because we know solutions always have to be ordered pairs. All right, moving on. Here's another example. We're still going to do the substitution method just so you can have a solid foundation of it. Here we have two equations. Obviously, step 1 is to solve one of the equations for a variable. Unfortunately, none of these two are solved, so we're going to have to do that ourselves. So step 1, again, solve one of the equations for a variable. It's up to you. There's no wrong answer. You could solve the first one. You could solve the bottom one. You can solve for x. You can solve for y. To make my life easier though, I chose the bottom one. I chose this one because look at that. The y is almost by itself. All I have to do is just throw this to the other side and I'm going to be done. So that's why I chose that one. But like I said, you could have chosen the first one. It's okay. Go for it. So I chose the bottom one. Like I told you, I just moved the 3x to the other side. It becomes a positive 3x and I'm already done. This equation is solved for y. The y is by itself. How do I know it has to be y? Like I said, it doesn't matter. You could have solved for x. I don't care, as long as you solve for a variable. So this one's already solved for y. Again, it's called substitution method because now since this whole thing is equal to y, I'm going to replace it on the y of the other equation. So since I use the bottom one, now I have to use the top one. So I'm going to replace all of this in the little y. So the y is going to disappear and it's going to be replaced by 3x minus 2. Okay, so hopefully you understood that part. Whichever equation you solve, once you get to step 2, you're going to substitute it into the other equation. So I have 2 equals 3x minus y. Obviously, the y is going to be replaced by whatever I got from step 1. Now, make sure you make a note of this. You have to put parentheses. Whenever you substitute, you have to substitute with parentheses because if you don't, you're going to get an incorrect answer. So I substitute with parentheses and that's it. That's step 2. Step 3, we're going to start solving. But hopefully I didn't lose you here. So again, this is how you know where to substitute. This whole thing is equal to y. So it's going to take place of the y in the other equation. Okay, so now we start solving. This is where we were so far. Now to solve this, I have to distribute. Remember, when you have a negative, it's distributed to both things inside the parentheses. So this is going to be 2 equals 3x minus 3x, and then the negative and negative 2 make it a positive 2. All right? Now, oh my goodness, something happens here, right? When we have the 3x and the minus 3x, those actually cancel out because 3 minus 3 gives me 0. So, the variables disappeared, and I'm just left with a 2 equals 2. So if I were you, I would be panicking like, oh my goodness, I did something wrong. But you didn't. That's it. That can happen. So if you remember from the previous slide, when things cancel out, you just ask yourself, okay, what kind of statement did I end up with? A false or a true statement? Since 2 is equal to 2, we ended up with a true statement. So we go back to our table, and our table says, and we end up with a true statement, we actually have infinitely many solutions. So this problem doesn't have one solution. It doesn't have 2, it doesn't have 3, it has plenty of solutions. So that's it, believe it or not. I know it looks weird, But that's it. You would just stop this problem and be like, this problem has infinitely many solutions. Again, I am going to warn you why. Because the variables disappeared. So there's no longer no x's, no y's. We just ended up with a true statement. That's what gives it away. All right, so just remember, true statement, infinitely many solutions. Okay, let's go ahead and try just a couple more. Here we have another one, but now let's go on to the third method. We're going to solve this one using the elimination addition method. Just so you guys know, if I get excited, it's because this is my favorite method. I love elimination. So again, I don't care. You could use substitution, you could use graphing, but this is personally my favorite method. So the elimination addition method is going to work. But remember, for this one, we do have also 4 steps. So step 1, both of the equations have to be in this format. They have to have the x's and the y's on one side of the equation and then the other number on the other side. As you can see, this one's already set up for us. Again, you have your x, your y, the number on the other side. You have your x, your y, and the number on the other side. So this one's already done. Now, step 2. This is where things can get tricky, you guys. I know you're going to be like, I hate this method, but it's okay. Step 2, we're going to have to modify the equations, okay? Don't freak out. Don't freak out. This is what we're going to do. The x's have to have opposite coefficients. So the 2 does not cancel with a -5. Now let's try the y's. The 3 does not cancel with a 5. So we cannot eliminate these yet. So we're going to have to manipulate the equation. So what I'm going to do, and just so you know, there's many correct answers for this, but what I'm going to do is I'm going to see if I can make this number into a 10 and this bottom number into a -10. Just so they can eliminate, because in order for them to eliminate, they have to be opposite numbers. Now, if for some reason you want to make the top number a 20 and the bottom number a -20, that also works, okay? This is a cool thing about the elimination method. You could make them into whatever number you want as long as they're opposites. Now, I know what you're thinking. What if I want to cancel the y's? Go for it. You can make this into a +15 and this one into a -15. That's okay. But for me, just to keep it simple, I decided to make the top number into a 10 and the bottom one to a -10. Now, my question is, how do I make a 2 into a 10? Well, I'm going to multiply it by 5, okay? Now, how do I make the bottom number into a -10? Well, all I have to do is multiply this -5 times 2, okay? So again, it's up to you, but the whole point of the elimination method is that they have to have opposite signs. So if I multiply the 5 times 2, it's going to give me a +10. And if I multiply the 2 times -5, it gives me the -10. And now finally they're opposite signs. But here's the deal though. If you're going to multiply the 2 by 5, you have to multiply all the equation by 5, okay? So obviously this gives us 10, but now I have to do it to everything. That's going to give me a +15y. And then the 5 times -12 gives me the -60. Okay, same thing goes with the bottom. If I multiply this by 2, I have to do it to all of them. So 2 times 5, that gives me 10y. And 2 times -20, it gives me -40. Okay, so you do have to multiply both or all the equation by the number, but just I promise you it's going to end up being so pretty. So this is the whole point of the elimination method. They have to be different signs so that they eliminate each other. Okay, so now that there are different signs, now this is why you're going to see that why we call it the addition method. Now that the equations are, they have different, now we're going to add them. Okay, so we're going to go ahead and add these 2 equations. You're going to see why they had to be different. Now, if you notice, because they're different, they eliminate when I add them. And I'm just left with this here. So 15 plus 10 gives me 25y. -60 plus -40 gives me -100. So again, the whole point of the elimination method is that I'm just left with one variable now. So I'm left with 25y equals -100. And now to solve this, I divide both sides by 25 and I end up with y equals -4. Since I already have one answer, oh my goodness, that was meant to be a square. Look at that. I already have the second part of my answer. This is going to be -4. Now I have to find the first answer. So step 4 is finding the missing variable. I know this is going to sound weird, but we are going to substitute back. This is not the substitution method, but if you already have one answer, you just plug it back in to find the other one. So since I know y is -4, I could substitute it to either one of these equations. You could choose whichever one you want. For this one, I just chose the top one. So 2x plus 3y equals -12. I already know that y is -4, so I'm going to replace this y with a -4. And then I just solve. So 3 times -4 gives me -12. And then I'm going to throw this -12 to the other side. And this leaves me with 2x equals -12 plus 12, which is 0. And then to solve this problem, I just divide both sides by 2. So I can leave the x by itself, and 0 divided by 2 is 0. And that's okay. So I know it looks weird to get an answer of 0, but since the x is still there, then that's it. That's my answer for x. So my answer is actually end up being 0, -4. I know what you're thinking. Why in the world is this her favorite method if it's super long? It does look super long, but trust me, once you get the hang of it, it ends up being super easy. So there you go. That's my answer for this one using the elimination method. Again, you could have solved this by graphing. You could have solved it by the substitution method. So if you don't like this method, then just practice the other one that you prefer. All right, let's go ahead and just do one more problem here. This one says solve the system of equations using the method you prefer. Like I said, you can use whatever you want, but you know me, I'm going to do the elimination method because it's amazing. So here we have two equations. If I'm going to do the elimination method, I have to make sure they look like this, right? So my x's have to be in one side, the y's in one side, and then the numbers on the other side of the equation. So this one is perfectly set up for the elimination method. Like I said, you could use whatever you want. And here's the cool thing about it. If you guys start doing this one by substitution and you end up that you don't like it, you could always like stop it and then go on to another method. So if you're halfway through one method and you just realize it's not working, you can always try a different one. So I'm going to start this one, the elimination. And again, it's already set up for elimination. The x's and y's are on the same side. Now, what I'm going to do is I'm going to modify the equation. So I'm going to modify them so that the coefficients are opposites of each other. So what I'm going to do here is I'm going to try to cancel out the x's. So in order to cancel out the x's, I'm going to have to manipulate them so they have different or opposite coefficients. Now, 2 and 3, what I'd like to do is think about the least common multiple. They can both become a 6. So my goal is to make them into 6's, one positive, one negative. So what I'm going to do is that I'm going to multiply the first one by 3. So if I multiply 3 times -2, it's going to give me a -6. Okay? Now, what that means is that since this is going to end up being a -6, the bottom one is going to have to become a +6. So what do I multiply by -3 to make it into a +6? So I'm going to have to multiply it by a -2 because -2 times -3 is going to make it into a +6. Okay, so I know it's like a little puzzle. It is going to take you maybe a few seconds to try to figure out what to multiply by, but once you got them, then that's it. So since I multiply the top one by 3, remember I have to do it to all of them. So 3 times 8 gives me a +24y, and then 3 times 20 gives me a +60. Same thing goes with the bottom. I have to multiply everything by -2. So -2 times 12 gives me -24. And then -2 times 28 gives me the -56. All right. Again, just double check. Both of these have to be opposite signs. Just as a reminder, you can also manipulate to cancel out the y's, just so you know. You could do x's or y's. It doesn't matter. All right. Now that my equations are ready, now I can add them. Again, remember, it's always going to be addition. That's why it's called the addition method also. So if I add these just like I want it, the x's canceled out. Oh no, but then I run into an issue. The y's actually also canceled out. So, oh my goodness. So I'm just left with 0 on the left side. I wanted just the x's to cancel out, but for some reason the y's also canceled out. And then on this side, 60 minus 56 gives me 4. So just like I told you, it's okay to freak out for a few seconds, but then remember when your variables cancel out, you just ask yourself, okay, it's okay, it happened, but now you just analyze the statement where we ended up with. Is 0 equal to 4? Hopefully you say no, right? So all the variables cancel out, which is kind of scary, but it's okay. We ended up with a false statement. So if you go back to your table, when we have a false statement, it means that this system of equations has no solution. So just so you know, if you would have done this the substitution method, you would have ended up with the same thing. If you would have graphed this one, you would have noticed that both of those lines are parallel. So they would never intersect, meaning that they would just have no solution. So again, for just in general, for any of these problems, just remember if you end up with this true statement, you have infinitely many solutions. If you end up with a false statement, you have no solution. And just so you know, again, as a reminder, feel free to use whatever method works for you.